Everyone, this is Lalita Singh and you are going to study science with me in class 7. Today we are discussing our 15th chapter that is called electric current and its effect. In this chapter you will learn about electric current, electric circuit, circuit diagram, effect of electric current and heating effect of electric current. Okay, just move to the chapter then. As you press the switch of a bulb, the bulb get on. Okay, it started to glow. However, when you touch the glowing bulb, what do you feel? You feel heat. Okay, whenever you touch the glowing bulb for a very longer period of time, what will happen? Your hands may get burned. Why do you think the bulb glow on pressing the switch on? What could be the reason for not able to touch the bulb? Okay, the answer of these all question is electric current, because the bulb is having a supply of electric current and these electric current causes the bulb to glow as well as to heat. Okay, we know that electricity is one of the most important form of energy, and in our previous classes we have learned that various aspects of electricity such as its sources, materials which allow it to pass through them, that is conductor, and those which do not allow them to pass through them is known as insulator. Some device based on it, its significance in modern life and also the danger and harm associated with it and precaution while using it. Now let us know more about electricity. The flow of electric energy or electricity is called electric current. Whenever we are switching the bulb on, there is a flow of electric current, right? And that is what the reason behind the energy which is produced in the form of light from the bulb. The electric current is usually measured in ampere and denoted by A, capital A. Ampere is denoted by a capital A. The electric current passes through the conductive material which is generally in the form of wire. However, on commercial scale, electric current is supplied through cables to our home, office, shop, factory, etc. Electricity is used for various purposes such as lighting, heating, driving, electrical equipment and many more. Okay, whenever we are using a geyser, what is the thing working over there? That is electricity. Whenever we are using a mixer grinder, what is the thing working over there? That is also electricity. So there are lots of devices which work on the basis of electricity. Whenever we are providing electric current to them, they will run, they will work, and otherwise they will stop. Okay, so what is electric circuit? We have learned a little bit about electric circuit materials present in the or substances or component of the electric circuit, right? The complete path of wire and electrical component through which the current can flow is known as electric circuit. The complete pathway through which the current can flow is known as electric circuit. For example, this is an electric circuit in which we are having a source of electricity, okay, the battery, then we are having wires which is connecting all the component of the electricity, and the bulb which is glowing to represent that electric current is passing through it. Understood? So whenever there is a complete pathway of wire and electrical component through which electric current can flow, that will be termed as electric circuit. The flow of electric current is prevented in case of any break in the circuit. Just assume that if the wire is broken, okay, if the connection is loose, so in that condition the current will never flow through it and the circuit will be broken. Understood? That type of circuit which is having loose connection or broken is known as open circuit. Okay, understood? Now about this is what the electric circuit real one. Okay, but we are using representing diagram to make a circuit. We are not always drawing the bulb and battery. For making battery, for making bulb, we are using their symbolic form. Okay, for example, this is the symbolic form of a battery. We have learned about in our previous classes. This is the symbolic form of switch. This is what? A bulb. Okay, and this is what? A wire. So in this way we are simply putting it over here, all the symbolic symbols together to make a electric circuit. Okay, see over here, the switch is open. It means the bulb is not glowing. Whenever the switch is open, the bulb will never glow. And when the switch is closed, the bulb will glow. Okay, understood? The devices are represented by symbols in a circuit diagram. As you can see over here, this is known as circuit diagram. This whole diagram over here, it is known as circuit diagram. Now let's talk about component of electric circuit. So first one over here we are dealing with is switch. This is the switch. Okay, this is switch. Now let's discuss about switches. Switches as shown over here, this is push switch, means whenever we will push, the circuit will get complete. On and off switch means we have to switch it on, switch it off. Okay, and this is two-way switches which is present in basically in torches. Okay, just what is over there? The switch that we use in a circuit is called key. It allows the current to flow after the button is pressed. Switch is an important component of circuit and is present in all the circuit because it is giving us power to let the current flow, to stop the current flow in the circuit. Okay, so it is very, very important. Switches is important component of circuit and is present in all circuits. There are different type of switches with different function. When you press the switch on, the position for a bulb or a tube light, it started to glow because the current is flowing through them. The circuit is now closed. Just see over here, if the switch is closed, okay, so the entire circuit will be complete and the current will flow through them. And if the switch is in off mode, what will happen? The current will never flow. Understood? In this way, this current will never flow. A cell or a battery is the next device. Okay, just see, this is a battery. A battery symbol or cell symbol is this one. Over here, the bigger standing line is representing the positive, whereas smaller standing line is representing the negative end of the battery. Okay, see, you can see one is showing a positive end and second one is showing the negative end. So, a cell or battery is used as a source of electricity. In most of the appliances where one or more cell is needed to get the electric current, you know that cell has positive and negative terminal that we have learned in the last class as well. The wire is attached to it. See, the wire is attached to both positive and negative terminal. Okay, 2 or 3 cells can be connected together like this. 2 or 3 cells can be connected together like this. The positive terminal of a battery will be connected to the negative terminal of the second battery always. This has to keep in mind while connecting the battery, that positive terminal of first battery will be connected with the negative terminal of the second battery, and negative terminal of second battery will be connected to the positive terminal of third battery. Understood? This is how batteries got connected with each other. Okay, next is conductive wire. Wire is obviously made up of conductive material. It is covered with plastic coating, which is a non-conductive substance or insulative substance. It is joined for the flow of current in a circuit. It passes the current very easily from one part of the circuit to another. And the wire covering that is made up of plastic, it helps us to use it, because if the wire is covered with insulator, we can touch the wire without getting electric shock. Right. Next is device or appliances. The appliances or a device which needs the electric current is also attached to the circuit so that we can see or we can use the electric current. It could be bulb, it could be a motor or heater, anything. Now next is ampere or voltmeter. You can see this is the symbol for ampere and this is the symbol for voltmeter. Okay, voltmeter. An ampere is attached to the electric circuit to measure the amount of current flowing through the circuit, whereas voltmeter attached to the circuit to use the measuring the voltage or potential difference between the circuit or potential difference in the circuit. Okay, now this is all. Now over here we are having certain symbol for circuit diagram. See over here, the component of electric circuit is given over here and their respective symbols are given in the second column. You can see cell is represented by this symbol, one bigger and the one smaller, whereas battery is represented by lots. Battery is what? Combination of cells. So combination of cell symbol is present over here to show the presence of battery. Okay, what is this? This is battery. Understood. Now next is bulb. Very easy. This is bulb symbol. Next is, this is wire symbol. Then this is switch. This is what? Switch. Both of these are switches. Okay, but one is in open condition and the second one is in closed condition. Okay, and the last one over here is key. Okay, this is key which is open, and now over here the key is closed. You can see all. Yes, and over here this is the one which is known as fuse, which we use in many of the devices to protect the device. Okay, so this is fuse. These are all symbols of the component of circuit. A circuit with an open switch is called open circuit, whereas a circuit with a closed switch is called closed circuit. Okay, understood? It should be noted that current cannot flow through an open circuit. It always flow through a closed circuit. For example, in the first diagram, current cannot flow. Current will never flow because it is open in condition, whereas you can see the closed circuit which is having a closed switch, the current will flow through it. Okay, now drawing a circuit diagram. How we are going to draw a circuit diagram? Very simple. We just have to use all the symbols which is present in table number 15.1 to draw the circuit diagram. Okay, let us draw a circuit diagram of electric circuit. Let's do. Draw first a symbol of the electrical component. All the symbol which you need to put in a circuit, you will draw them, and then you later on you will connect each of the symbols together with the wire. Okay, that wire symbol is a plain single line. Join them all with the line representing the connecting wire, and your circuit will be ready. Okay, now notice the bulb in the diagram is glowing or not. Depending upon the switch's condition, it should be okay. Like if the switch is on or switch is closed. Okay, if the switch is closed, then the bulb will glow, and if switch is open, the bulb can't glow because the current cannot flow through it. Understood, class? Now, condition necessary for electric current to flow in an electric circuit. What are the conditions? The first, electric circuit should be complete. Okay, that is, no part of the electric circuit should we have loose wire or broken, or it should have a closed switches and key. Okay, second is the path should be closed, that is switch or key should always be in on position. Each part of the circuit should be made up of a good conductor. Okay, even though if the switch is closed, but there is some material which is made up of insulator present between the two wires, still the circuit will be considered as open because there is the presence of insulator which is not letting the electric current pass through them. Understood? Now over here, next topic is effect of electric current. Electricity has various type of effect on an object when it passes through them. Okay, for example, if it is passing through a solution, it can bring out chemical change. Okay, can make different device. Okay, can make different device to work. Next is, can make an object to behave like a magnet, and also can make an object hot. So over here it is having different effect. Like when it is bringing out chemical change, it is called chemical effect. When it is making the device work, it is called mechanical effect. If it is letting the devices or equipment act as a magnet, it is known as magnetic effect. And if it is making the object hot, it is called heating effect. Understood? Now let us study about heating and magnetic effect of current in detail in this chapter. Understood, class? Electrical devices such as water pump, mixer, grinder, washing machine, fan, cooler, etc. work due to mechanical effect, and electroplating or that is layering of one metal over another, is done on the basis of chemical effect of electric current. About that you will study in class 8. Okay, now heating effect of electric current, that is the first thing that we will deal in this chapter. Okay, you might have seen an electrician or the elders at home removing a light bulb from the holder. Do you think, or have you ever noticed that what they do? They are suddenly going to touch the bulb with their naked hand, or they are going to use a handkerchief. They always use a handkerchief or any kind of cloth. Why? Because the bulb is hot over there. Have you ever thought why the bulb which is lighted become hot? To find out the answer of this activity, let us do an activity. Okay, to find out the answer of bulb why it is hot, we can do the activity number 1, to study the heating of glowing bulb. Okay, for this we need a torch bulb, okay, connecting wire, a cell and switches, so that we can connect all of these together. Now what is the procedure of doing this? Connect the torch bulb with the cell and switches with the help of connecting wire. Switches on the bulb, and when connected, just switch it on. Okay, and then turn it off after 2 to 3 minutes. Touch the bulb carefully on its glass body. What do you observe? You will observe that after letting the bulb glow for 10 minutes, the bulb is now what? Little bit warm. Okay, the bulb is now hotter in from the first case when you have switched the bulb on. It means the bulb become hot just because of the passage of electric current through its circuit. Means when the bulb glow, it become hot. Understood? Clear? So this is what? This is due to heating effect of electric current. It is important to note that not only the filament of bulb, but every wire or every device which is letting the current pass through them, they become hot due to heating effect of electric current. Understood? Now, there are many electrical devices which work on the basis of heating effect of electric current. For example, electric heater, electric kettle, electric toaster, electric iron, oven, geyser, hot plates, hair dryer, etc. These devices have coiled water called an element, which on passing electric current become red and hot and give out heat, and they are giving out heat because of heating effect of electric current. Okay, the amount of heat produced by element is based on the following factor. There are some factor which is affecting the amount of heat that is generated through the wire. What are the factors? First, the material of the element. What type of material has been used to make the coil of wire? Okay, that is very important. Second is the length of wire in the element. What is the length? If the length is too much, okay, so obviously heat but that is being created over there will be larger. If length is short, then heat will be less. Okay, now next is the thickness of wire in the element. What is the thickness of wire? Because the more the thickness will be and the more heat will be produced. Okay, the time for which the electric current flow. Obviously, if you are letting the electric current pass to the wire for a longer period of time, then they will produce more amount of heat. If you are letting the electric current pass through them for a shorter period of time, they will what? They will produce less amount of heat. Okay, this heat is generated over here because of the resistance that is caused due to the wire material. Different material get heated to different extent on passing the electric current through them. Okay, different kind of material get heated at different level. Why? Because the property of there that is called resistance. The resistance hamper the flow of current through a material. Material having high resistance produce a large amount of heat, whereas material of low resistance produce a very small amount of heat. Silver, aluminium, copper, okay, become the least hot, whereas material like tungsten and nichrome get too hot on the passage of electric current. That is why we are using tungsten in the bulb filament. Okay, the bulb when it glow due to the heating of tungsten. Tungsten is a material which produce a large amount of heat while when the current pass through it. The property of tungsten and nichrome make them useful for making filament of electric bulb and electric element of heating device respectively. They have the ability to withstand a high temperature without getting melted. Beside giving light, an electric bulb also give out heat which is not desirable because it consumes more electricity and cause wastage of it. However, using fluorescent tube and compact fluorescent lamp CFLs is better option as they produce light by using small amount of electricity. Hence, they save energy and reduce its wastage. So, the electric bill will also be reduced. Now, think about what happens if the amount of current passing through a material increase. Let us find out this with the help of an activity. See, this is the activity 2 in which we are going to study about the effect of amount of current passing through a material. For that, we are going to need certain material like 3 torch bulb, 6 cell, 3 switches and connecting wire. Because we are going to perform these activity, so what we have to do? We have to make 3 circuit as shown in figure. Okay. And to make the circuit, we will need battery, wire and bulb. Okay. The first circuit will be made with the single battery, where the second circuit is made with the help of 2 battery and third circuit is made with the help of 3 battery. Okay. And now we will switch on all of these circuit together. Okay. Now, just after few minutes, switch off the bulb. Okay, switch on or make the connection loose. Now what will happen? The bulb in the second circuit is hotter than the first circuit. You will observe this. When you will touch the bulb, okay, of the circuit, you will observe that the bulb in the second circuit is hotter than the first one. Okay, but what about third circuit? It is having 3 batteries. It means it will be the hottest among all the 3 one. Okay, and the coldest one will be the first circuit because it is having only 1 battery. So the amount of electric current produced can also get increased when we are increasing the number of battery. Okay, and because the because the electric current flowing through the wire has got increased, the bulb also produce more amount of heat. Understood? The bulb is glowing in the third circuit. They are producing more amount of heat. Why? Because they are having larger current supply. Understood? Now over here the next topic is an electric fuse. See, I'm sure you have seen this electric fuse. Okay, this is a small electric fuse which is basically used in small devices. Okay, in case the electric supply of your room or home is suddenly put out, you realize that all other houses in neighborhood are getting the electric supply but your house is not. What will you do, or what will your elders do at that time? They will go and see the fuse. Okay, is the fuse in correct order or not? Okay, why? Because maybe possible the fuse had disconnected. Okay, maybe possible the wire of the fuse get melted. Understood? Now just study the structure of fuse. This is what a fuse look like. Just see, there is a small thin wire which is connected the 2 edges of the fuse. Understood? Now over here you can see there is also a thin wire which is connecting the 2 edges of metallic substances. So what is the structure of a fuse? A fuse is a safety device which limit the current in an electric circuit. If the current in the electric circuit is a specific value, okay, the fuse wire will melt and break the circuit. It is because of the production of heat through the wire. Okay, so basically fuse is also made based on heating effect of electric current. When the current will when the current which is passing through the device, when passed through these which is present in between the two part of the circuit, okay, with the help of this thin metallic wire, it is letting the current flow through it. If the amount of electric current which is flowing through it get exceed to the certain limit, what will happen? This wire will melt over here. This wire will get melt down, okay, and in this term it is making the circuit now open, and it is protecting the device just by making the fuse break. Understood? The common type of fuse consists of a Porcelain holder, you see, fitted with a metallic terminal. The thin fuse wire made up of tin or alloy of tin and copper is screwed between these two terminals. You can see it is screwed between the two terminals over here. The holder fit perfectly in this socket. This holder will be fitted into this socket to make the circuit complete. Okay, to make the circuit complete. When the holder in its position, current will flow into the circuit. All the expensive and sophisticated electrical devices have a built-in fuse. The shape and size of the built-in fuse is different depending upon the size and shape of the instrument. Okay, understood? The shape and size can be different, like this is like it appears like this. Over here we are having second picture of fuse which is little bit different. Now next is application of fuse. Here do we use this fuse? Production of heat in any circuit is very normal behavior because of the heating effect of electric current. Sometimes a circuit may get overheated due to overloading. In this situation, the fuse melt a little before any other part of the circuit could because it is thin. Okay, they stop the flow of current and further heating on or burning of the circuit of the device. Okay, just imagine if the fuse will not melt down, what will happen? Other circuits of the devices will get burned, they will get damaged, and it will cost a lot there. Okay, so it will be very costly to repair them in that condition. It is better that the fuse can get melt before the device can. Okay, a fuse is a safety device of an electric circuit. It makes use of heating effect of electric current to save the possible threat of fire. A fuse can be easily replaced after getting blown off, but before replacing the fuse, we must ensure the reason behind the blowing of the fuse must be checked and corrected properly. Now, this is MCB. This is what? This is MCB. MCB means miniature circuit breaker. It is basically applied in every houses to ensure the safety. The miniature circuit breaker, that is MCB, is an alternative to an electrical fuse. It is convenient to use because it is automatically turned off when the current in the circuit crosses the safe limit. To complete the circuit again, we just have to turn it on instead of replacing the whole metal wire. Okay, as we have to do it in the electrical fuse. The reason for choosing a material as tin or alloy of tin, copper to make fuse wire is that these material have a melting point lower than that of normal wire or device, and it is very very essential because if the melting point had been crossed by the heat produced by the electric current, only then can fuse can get melt. Okay, so we are using them. Now while buying an electrical appliances, we must check the star mark or star rating given to them. Okay, we should check it for SI mark as well. SI mark has been provided by Bureau of Indian Standard. This mark ensure the safety and energy consumption of the device. You can see over here, this is the star rating of a device. Energy label system for refrigerator, tubular fluorescent lamp, or air conditioner in India has been launched by Bureau of Energy Efficiency, BEE. The Bureau is responsible for improvement of energy efficiency through various regularity and promotion instrument. Commonly, energy labeling is known as star rating. The BEE label display on a product indicate that its energy efficiency. The label has a rectangular base. You can see it is a rectangular base over here and a semicircular top with 5 star. Number 1 to 5. An indicator on the semicircle top show what star rating the product has earned. The number of star will be more and more efficient the device will be, more low amount of energy will be consumed by the device. So class, up to over here we have discussed, and the next topic is magnetic effect of electric current, that will be discussed by us in our next video. Until then, have a nice day everyone.